Today's lesson is on section 3.3, which is the first derivative test. To begin with, you see your homework assignment there. It's out of section 3.3, 17 through 45, every other odd, which means 17, then 21, 25, 29, etc. And this assignment will be due Wednesday in class. So let's look at the first derivative test. The first derivative test is going to allow us to find relative minimums or maximums, not absolute. That's the extreme value theorem. That was back in section 3.1. Now I just want to find the relative mins and maxes. I'm going to use the first derivative test. And again, a relative min or max is usually where the parabola reaches the highest point, maximum, or like a parabola or a curve, the minimum. Let C be a critical number of a function f that is continuous on an open interval called I containing C. One more time, I can't spell. So again, my function f is continuous, and on some open interval I, let there be a critical number C. So far it looks like I'm supposed to find critical numbers. Then, if the first derivative or the slope changes from negative slope to positive at this x equals c at my critical number that I just found, comma, then f, my original function, has a relative minimum. Where? At wherever this c value, this x value that you found, this critical value, and I plug it into the original function to get the y output. This is exactly what we did Friday in class. We found the critical value, we put it back into the original function to get the y value, and that will be my minimum. Or, if the first derivative, in other words, if the slope of the tangent line changes from positive to negative this time at this x equals c, what is my c? It's my critical number. Then f has a relative maximum. And where is this relative maximum? At whatever this value is, we plug it back into the original function to get my y. So again, first I have to find my critical numbers. My critical numbers are found two ways. By taking the first derivative and finding out where it's 0, where the slope of the tangent line is 0, or finding out where the first derivative is undefined. Then I take all those critical numbers, I plug them into the first derivative, and I find out what it produces, negative or positive values. And we'll do that here in a moment. So I have two possibilities so far. Negative to positive on my slope, it's a relative min. From positive to negative, then I have a relative max. So let's see, from negative, might have a negative slope to positive. And this here could be my C. Or from positive to negative, that would be my C. And there's one other possibility in my first derivative test. If the first derivative, or the slope of the tangent line, is positive on both sides of my critical number, or negative on both sides of my critical number, then f of c is neither a relative min or a relative max. So it could be something like my original function looks like this. So I'm going to get my critical value because this slope is 0, the tangent line, but it is positive and positive. It's positive on both sides of that C value. For negative and negative, maybe it's like this. Again, that's a negative slope, but I still, for the original function f, but my first derivative is equal to 0, just like my first derivative here is equal to 0. So let's sum all of that first derivative up into some steps. I'm going to take that whole first derivative test. So first thing I need to do is take the derivative. Why? Because it told me my first derivative test to find the critical numbers. How do we do that in section 3.1? We take that first derivative once we have found it and set it equal to 0, find out what x values allow me to have a slope of 0, or to take the first derivative and find out for what values of x is it undefined. Once I have done that, once I have found my critical numbers, let's go ahead and throw them in my original function, just like I did in 3.1. And that way I will get my ordered pair C, f of C. And what are these? These are the possible relative maxes and relative mins, because these are my critical numbers. Most of them are going to be relative max and mins, but not all of them. 4, I'm going to create a sign chart with the critical numbers and test values, and I'm going to test for the slope of the tangent line. I'm going to test those slope values, and what am I testing for? I'm going to take those critical values, and I want to find out, I'm going to test my test values to find out if it's positive or negative. Then this will be my conclusion statement. My conclusion statement is choosing which scenario I find out it to be from doing my problem. So here is my conclusion statement. Since the first derivative of x changes from either negative to positive or positive to negative at x equals whatever your critical value is, then f, my original function, has a relative min or max at that ordered pair. Done. So let's do a problem. I'm going to do 2 problems. First one I'm going to do is number 19. Here's my original function. And I want to use the first derivative test to find any relative min or relative maxes, not the absolutes, relative. So the first step, as I had said, was to take the derivative. So let's do that. Done. Second was to find any critical numbers. How do I do that? I'm going to set this equal to 0. So when x equals 1 is my first critical number. And I had stated in step 3 to go ahead and evaluate or take this and put it back into the original function to find that ordered pair. So I get the ordered pair 1, 5. That could be a relative min or a relative max. Again, there is no other x value that will have a slope of 0 for the tangent line. The second way of finding a critical number is what value of x in this first derivative could it make it go undefined. And there isn't anything. For undefined, I need a square root or I need a fraction. And I don't have that. So there are no other critical numbers for me to look at. Now let's go to step 4. Step 4 was my sign chart. So let's go ahead and create my x-axis, or a number line. I'm going to put on it the critical number 1. So on my original function, at 1, I could possibly have a relative min or a max at 1. So I'm going to pick a couple of test values on either side. I could pick any number I want, because again, at 1, either somehow the function has a max there, or somehow there's some kind of a min there. So on one side the slope is one way, on the other side the slope, on this side the slope is negative, on this side it's positive, or on this side it is positive, or on this side it is negative, which will determine if it's a max or a min. So a test value, anything less than 1 would be 0, anything above 1 I'm going to choose easy test values. So this is to test slope, and this is my critical numbers down here. So in step 5, and let's put this down, sorry, too early. For my sign chart, I want to put f prime and f here. I'm going to answer some questions as I do the first derivative test. So step 5, I'm going to test those test values into my first derivative. Let's see, it's right back up here. So I'm going to test this test value of 0. Negative 4 times 0 plus 4, that equals 4, but most importantly I just want to know if it's positive or negative. That is positive. So for my first derivative for 0, it's positive. And my first derivative, I'm going to test the other test point for my slope, put in 2. That's negative 8 plus 4, which equals negative. I don't really care what the value is. I just need to know if it's negative or positive. So on the original function, if the slope below 1 is positive, then my original function must be increasing. Over here on the other side of 1, if the slope is negative everywhere past 1, a negative slope, then my original function is a decreasing function after 1. So it is going to look like, let's see, so before the 1 it's going to be increasing, so it's going to look like this one. It's going to be increasing, then decreasing. The slope goes from positive to negative. So it looks like this one. So 6. Here is my conclusion statement. Since the slope f prime of x changes from, okay, right here, changes from what? Positive to negative at x equals where? At 1. Then f, my original function, has a relative, well, let's see, from my picture it looks like a relative max. Let me take a look at the first derivative. Let's see, positive to negative. Let's see, from positive to negative, yes, it's a maximum. Then f has a relative maximum at, oh, well, I have not done that value. Oh, yes, I have. I've done it right here at 1, 5. Done. I'm going to work on a second problem, and then I will be done for today. The second problem will produce a little bit of an issue, which is why I want to show it to you. Be number 27. So the original function f of x is x to the 1/3 power plus 1. So step 1 is to take the first derivative. And I'm going to go ahead and proceed to clean that up a little bit. Let's see, negative 2/3, so the 1/3 means a third root. The negative, means to put it in the denominator, so it's an x squared. So that is my first derivative. Step 2. I'm going to try to find my critical numbers. So I'm going to set this equal to 0. A critical number is where the slope of the tangent line is equal to 0. I might have that relative min or max as I'm taking my tangent line, going around the original function. Where is it 0? And so again, this whole thing is 0. Well, I'm going to multiply both sides by this, except when I put that over here, 0 times anything is still 0. This is canceled out, and 0 does not equal 1. So I get no critical values from here, none. Well, the second way to get a critical value is if I take a look at this first derivative. Again, I know it's right there. I'm just going to copy it again. And I look to see what values of x could actually make this undefined. Well, undefined is when your denominator is equal to 0. So, in other words, here's the denominator and my square root. So, if x squared was equal to 0, this would be 0. 0 times anything is 0. I cannot have that. I cannot have that. So x cannot be 0. So in other words, x equaling 0 is a critical number. That value, 0, makes this first derivative go to undefined. The denominator is 0, hence this fraction is undefined. So I found myself a critical number. Number 3. I'm going to take that critical number and find that ordered pair back in my original function. So that'd be 0 to the 1/3 power plus 1, which equals 1. So that ordered pair is 0, 1. This could be possibly a relative min or a relative max. Okay, so that's my only critical number is 0. So now I'm going to proceed to step 4 to do my sign chart. I have one critical numbers at 0, so 2 test points to test the slope of the tangent line before and after 0. I could choose -1 and 1. So this is to test my slope, and this is my critical number. And I want to find out if my slope is positive or negative, and I can state if the function is increasing or decreasing. Well, how am I going to do that? In my first derivative, I'm going to put my test points of -1. Let's see, where's my function again? Oh, there it is. 1 cube root -1 quantity squared. 1, 3. That's 1. The cube root of 1 is just 1, and 1 times 3. So that is a positive number. Now let's put in the second test point into my first derivative, because I just want to see the sign of the slope. Is my slope positive or negative? Oh, it looks like it's going to end up being the same thing. So much not the number as it is the answer is positive. My slope is positive. In other words, my function is increasing, and it is still increasing. Okay, so let me go back to my notes just for a moment. I don't know if you remember in this third scenario in the first derivative test that sure, I could get a critical value where the slope is going to 0, but it's decreasing and decreasing or increasing and increasing, and this point here, this C, is really not a relative min or max at all. It's not my highest or lowest, like these two could be. So now I have to write out my findings. Since f prime, or my first derivative, is positive on both sides of x equals 0, which is my only critical number, then there is no relative min or relative max. Done.